today we will start with the first lecture of part 3 of our course. As I said at the beginning of the semester that we have 3 parts. We have finished part 1 where we were still in the university, part 2 we finished it, online learning, and now we are starting the beginning of part 3. So today's lecture is gonna be about the maximum and minimum values of any function. So for a function to find its absolute or global maximum or minimum, the absolute or the global maximum is going to be the highest value, the highest y in your function. If you look like this, you will find that this point represents the highest y value. So therefore at d, f of d, this is the global maximum. What about the global minimum? The global minimum, you're going to check in your function or graph the lowest point, the lowest y value. So I think it's a. So the lowest y value is going to be f of a and at point a. So in general, to find the absolute or global maxima or minimum, we're looking for the highest y value or the lowest y value. Let's take this example. Which of the following functions have an absolute maximum or minimum? So f of x equal x squared, and he didn't say any domain, so it goes like this. So if I have something like this, the global minimum will be 0, 0. What about the global maximum? The global maximum does not exist because it's infinity, because he did not say a domain, so it goes from negative infinity to positive infinity. Then the same function but with a domain of negative 1 from here till 2 over there. So the global maximum will be 2 and the global minimum will be 0. F of same function, f of x equal x squared, but from 1 to 2. From here to there. But 1 is opened. Alright, so the global minimum does not exist. The global max will be 2. Alright, for this function or graph, identify the absolute maximum or absolute minimum. Okay, let's look for the highest value. Here it is. So the absolute maximum will be f of s. Absolute minimum, let's look at the lowest y value, smallest value. Here it is, so it is at r. Then he's asking about something else. He's saying local max, local minimum. What is a local maximum, local minimum? Alright, a local maximum, local minimum represent values, also a small value or a higher value, but within a certain interval. For example, if you look from point A to point C, here it is, I can say that the local minimum is point B, because point B have a relatively in just this part, the lowest y value. Alright, if I look from B to D, I can say that there is here a local maximum from B to D. So it's the same idea of the absolute maximum, absolute minimum, but the difference is that we look into local parts in the whole function. We don't look at the whole function. At the whole function, it's going to be absolute max, absolute minimum. But if you look at smaller intervals in your function, it's going to be a local minimum here, or if you look from B to D, you're going to have a local maximum at C. From D to S, you can have here a local minimum at R as well. Okay, so think of it like when you're having a competition, maybe through all the country, and then you have a competition within your school. All right, the local is within your school because you're looking into a smaller part. Alright, here comes our first theorem that is related to local maximum, local minimum, and global maximum, global minimum. This theorem is called Fermat's theorem. Fermat's theorem tells you that if the function has a local maximum or minimum at C, for example this point, this is a local max. As you see, if you take this interval, this point have the highest y, so it's a local max. Then the derivative will be equal to 0 if it exists. So if there is a derivative, you remember derivative is the slope or the tangent drawn, and it will be equal to 0 because it's going to be horizontal. The same here, if this is local minimum, it's going to be the same. Here comes another definition that we're going to use. Critical number, alright? A critical number is a number in the domain of the function that either the derivative is 0, either the slope is horizontal, or it does not exist. f dash of c does not exist. And if the function has a local max or local minimum at a certain point, for example c, then this point is a critical number of the function. All right, let's find our first example. Find all the critical numbers of this function 2x squared plus 8x. Okay, the theorem tells me that a critical number occurs if the derivative equals 0 or does not exist. Here, if you do the derivative, you have 4x plus 8. For x plus 8, you can have the option of having it equal to 0. You cannot have it does not exist, because does not exist means, if you remember, that you have a function with a denominator and the denominator is equal to 0. So here you just have a numerator, so you will take the first option, that the derivative equals 0, and you find the critical number at x equals -2. Another example, find the critical number of this function, polynomial function of third degree. Again, critical numbers occur when the derivative could be equal 0 or does not exist. So here I just have a numerator, so I will set the derivative to 0, I will solve it, and I found the two critical numbers. Another example, find all critical numbers of the function g of x equal absolute value of x minus 1. Okay, before I find the critical numbers, I will redefine my function. Absolute value, x minus 1 is going to be negative x minus 1 if x is smaller than 1, and it's positive x minus 1 if x greater than or equal to 1. This is the function. Again, critical numbers occur when the derivative equals 0 or does not exist. Alright, so let me see. I'm doing the derivative of this function. It's -1 when x less than 1, it's +1 when x greater than or equal to 1. If you remember, I can also say that the derivative does not exist if the right and left limits or the right and left derivative at the same point do not agree. At x equals 1, you have -1 from the left and you have +1 from the right. Therefore, the function does not exist at x equal 1. So x equal 1 is a critical number. Alright, find all critical numbers of this function. Okay, critical numbers occur when the derivative equals 0 or does not exist. I will first try to make the derivative equal to 0. So I got the derivative of the function, and then I reformed it to know what's in the numerator and what's in the denominator. To set the derivative equal to 0, you set the numerator equal to 0, and I found the critical numbers at x equals 0 or x equals -2. The other option is to set the derivative to do not exist. This happens if the denominator is equal to 0. So I took the denominator of the functions, I took a common denominator of the function and I set it to 0, and I found that this happens at x equals 0. So I have two critical numbers at x equals 0 and x equals -2. Alright, here comes another theorem or another method that we can use to find the absolute maximum or absolute minimum. It's called the closed interval method. Alright, to find the absolute maximum or minimum of a function that is continuous on this interval closed a to b. First, I need to find the value of the critical numbers. So I need to solve for the critical numbers. Then I solve for the value of the endpoints of the interval. I need to know what is the y value at x equal a, what is the y value at x equal b. Then I will check the largest of all the values will be the absolute maximum, and the smallest of all the values will be the absolute minimum. Alright, this is the method. Let me summarize it here and show you how we're going to do. I'm going to summarize it into 4 points. First point, I need to prove that any function I'm trying to find its absolute maximum or minimum is continuous on a certain domain. Then I will find the critical number. Then I will substitute with the starting and ending points of the domain and find their y values. I will choose the largest of them to be the absolute maximum. I will choose the smallest of them to be the absolute minimum. Alright, let's take an example and use these steps, and it's gonna be very easy. Okay, find the absolute maximum and absolute minimum value of this function. He gave me the function, it's a polynomial function to the third degree, and he gave me a domain as well. So the steps. First step, I need to prove it's continuous. Alright, it's a polynomial function third degree, and polynomial functions are continuous on their domains. Here it's given from 0 to 1, so it's continuous from 0 to 1. Step number 2, to find critical numbers. Finding critical numbers, you either set the derivative to 0 or does not exist. Here, you can set the derivative to 0. So I differentiated and I set it to 0, and I found that x could be 1/3 or -1. At this point, I need to check, are these points in my domain or not? I have -1, but my domain starts from 0. So it's not in my domain, so it's rejected. And then I found the value of y, f of 1/3 is minus 0.962. So I got the critical point 1/3, and this is the y value of the critical point. Third step, find values of the endpoints given. I have from 0 to 1. I need to find f of 0, I need to find f of 1. F of 0, -1, f of 1 became 0. I just substituted in the original equation. And then I check. I have now minus 0.962, minus 1, and 0. What is the largest value of these? 0. So the absolute maximum happens at 1, 0. What is the least value? -1. So the absolute minimum will be 0, -1. Another example. Find the absolute maximum and minimum of this function. Again, a polynomial to the second degree, and the domain is given. Polynomials are continuous on their domain. I need to find the critical number. I differentiated. I set the derivative equal to 0. And then I found the critical number at x equal 2. I substituted in my equation x equals 2 and found that y equal -4. Then I need to find the value of the endpoints, which is 0 and 7. So I substituted at 0 at 7, and I found y 4 and 46. I took the maximum y value, which is 46. Here it is. This is the absolute maximum at x equals 7, y equals 46. And the absolute minimum will be 2 and -4. All right, here comes our last slide. And this slide is actually checking the concepts. It has to do with the wording of the theorem itself. So if you're not sure of any of them, go back to the wording of the theorem and you will understand. So let's start with the first one. If f has an absolute minimum at c, we're talking about an absolute minimum or maximum, then the function has to be defined. Of course, yes, you cannot record or you cannot find an absolute maximum or minimum if the point is not defined. 2. If f has an absolute maximum, then f is continuous at c. No, that's not true, because sometimes the absolute maximum could be an endpoint or a starting point of your function, and this point is not continuous because it just has the function starts from the right hand side or just starts from the left hand side, so it doesn't have to be continuous. 3. If f has a local maximum at c, then f has an absolute maximum at c. No, that's not true. It could have a local maximum at a point, and the absolute maximum is another point. They don't need to be the same point. By the way, usually the local maximum, local minimum are not endpoints. Endpoints are recorded as absolute maximum or minimum. Local has to be in between the function, within the proximity of the function, not the starting or the ending of the function. If f has an absolute maximum at c, then f has a local maximum at c. No, that's not true. It could be the absolute maximum is the local maximum, and it could not be. So you cannot say that this is true. It's false, because it doesn't need to be. It doesn't have to be. 5. If f has a local extrema, then f dash of c equals 0. Again, it doesn't need to be f dash of c equals 0. There is another option that the derivative does not exist. So this one, it doesn't need to be always the same scenario, so it's false. Question 6. If the derivative is equal to 0, then f has a local extrema at c. This is not true. There is some functions where the slope is horizontal or their derivative is equal to 0, but it's not a local extrema. For example, you can draw the cubic function. Draw y equal x cubed. Alright? Check the slope at the point 0, 0. You will find that the slope is horizontal. However, it's not a local extreme. Alright, here comes the end of our lecture. I hope that it was clear, and if you have any questions, you can always email me or send me. And see you next lecture.